let's roughly go through what does it mean by thermal conductivity. So thermal conductivity has a symbol of K and it represents a measure of the material's ability to conduct heat. So if you have a material with high thermal conductivity, that means that it can conduct heat very well. So what does it mean by conducts heat very well? It's more efficient in conducting heat. Heat transfer occurs at a higher rate under the same difference in temperature. So let's say the difference in temperature is 100 degrees Celsius between these two ends over here. If we say this rod has a high thermal conductivity, that means that a lot of heat is transferring through this rod for every second that has passed. So you can think of it as maybe 100 joule pass by for every second, 100 joule pass through this rod per second. Okay, something like this. Okay, so if you have a material with low thermal conductivity, okay, this should be changed to low. Let me edit it. A material with low thermal conductivity, what happens is it's less efficient in conducting heat. So heat transfer occurs at a lower rate under the same difference in temperature. So it's the same difference in temperature, which is 100 and 0. The difference in temperature is 100 degrees Celsius. But if you have a material with lower thermal conductivity, you can expect probably it transfer maybe 1 joule of energy through the rod per second. Instead of high thermal conductivity, you transfer 100 joule of energy through the rod per second. So it's the amount of heat that you can transfer through the rod for every second that has passed. Greater thermal conductivity, greater amount of heat that transfer through the rod per unit time. Okay, so every different material has its own thermal conductivity, and this value here, thermal conductivity K, depends on what type of material that you are using. You change the material, you change the thermal conductivity. If you shape the material into different shape, you still have the same thermal conductivity. Okay, so it only depends on what material you are using only. So here we pop up a graph or a table over here showing that for different types of material, they have a specified value for thermal conductivity, and these are what has been measured in the lab for different materials, different gases, different materials. You have different thermal conductivity as listed here. Okay, the unit is a bit complex, but it's just using the same formula that you see just now. You're using the same formula, just flipping it around. Okay, you are just adjusting this equation to make K as our subject, then you can determine the unit that way. Okay, so it's just a simple rough idea of what is thermal conductivity because we never really explain it in detail. Okay, so that's it for thermal conductivity.